S. Chand presents educational video lectures as per the new UGC curriculum. Difficult concepts made easy. Study anywhere, anytime.
We are doing the course Business Mathematics, and in that the topic that we are covering is related to linear programming problems, and the context is Big M method.
If you want to study this topic in detail, refer to these books from S. Chand Publishing and Vikas Publishing House. Link is provided in the description box.
Welcome to S. Chand Academy, and I am Anmol Bhatia. So what happens in the linear programming problems, you have the constraint equations, and in those constraint equations the inequalities may be of less than type or it may be of more than type. So in our previous videos we have covered the cases of constraint equations which are less than equal to type, but we will be dealing with the constraint equations which are more than equal to type in this part of the video. So as I have already mentioned that the topic that we are doing is Big M method, and straight away we are coming to the problem. So in this linear programming problem, you have a condition. That means we have an objective function. So you have z, which is 6x plus 4y, and we want to get the values of x and y subjected to the following constraints, and the constraint equations are less than type. This is also a less than type constraint, but this type of constraint is a more than type constraint. So just for the sake of summarization, let me tell you that if you want to convert this less than type constraint into an equal to type constraint, what you need to do, you need to add a slack variable to it. If it is more than equal to type constraint and you want to convert it into an equal to type constraint, what you will do, you will subtract the surplus variable and you will add an artificial variable to it. And if it is equal to type constraint, so you need to add an artificial variable to it in order to fit in, or in order to convert these equations into the equalities, these inequalities into equalities. This thing I have already explained in detail in my previous videos. If you haven't watched those previous videos, you can log into S. Chand Academy channel. So the first and the foremost thing is to convert these constraints into an equality type. So initially it has less than type constraints, so I have added a slack variable. Here also I have added a slack variable. And if it is more than type constraint, I need to subtract the surplus variable and add an artificial variable to it. So it will be converted into an equality. And also I need to convert this objective function. So objective function would be converted like this. So 6x plus 4y is already there, and you have used these S1, S2 and S3 terms. So 0 S1, 0 S2 and 0 S3, that is to be written over here, and the method is Big M. So in order to use that concept, the artificial variable is already there, and we need to multiply this artificial variable with a quantity m. That quantity is a large quantity. That quantity would be a larger quantity that may be having some value which may be 100 or 1 lakh or 10,000. So that value is a bigger quantity, and I need to multiply it with a1 and subtract it from the objective function. So this is the particular form of the standard conversion into the standard form. Then what happens, you need to make a table, and the format of the table remains the same that we have already seen in the previous videos related to the linear programming. So the format of the table is CB basis solution and all those decision variables and other variables. So decision variables are x and y, and the other variables are S1, S2, S3 and artificial variable. So from the objective function, which was having the constraint equation 6, 4, constraint coefficients as 6, 4, 0, 0, 0 and minus m. So I had to substitute all these values with the Cj part. So 6, 4, 0, 0, 0 and minus m. And these bases would be filled from the objective function from the function which is other than objective function, which is the constraint equation, which are S1, S2 and S3a values. So from these you have to choose this S1, from these you have to choose this S2, and you have to choose or you have to make a decision from choosing from S3 or artificial variable. So if there is a choice between these S variable and artificial variable, you have to choose this artificial variable initially to be placed in this table. So S1 is the first basis, second is S2 and third would be A1. And CB indicates the coefficient of these variables from the objective function. So S1 is having a coefficient of 0, S2 is having a coefficient of 0 and artificial variable is having a coefficient of minus m. So I have substituted these values. And what about solution? Now, solution is the right hand side part, and as per the general rule we have to keep these values as positive. So 30, 24 and 3 are to be kept as the positive values. If they are not, you have to convert them into a positive value. 30, 24 and 3 is to be written over here in this column. And for the rest of the elements, I have to look for the constraint equation. Like for the first one, the constraint equation's coefficient is 2, 3 and 1. So I have to substitute them accordingly in these places. The equation was 2x1. So x coefficient is 2, the coefficient of y is 3 and the coefficient of S1 is 1 and rest of the things are 0. Similarly for the second and the third equation. Now we are left with these two quantities which are Zj and Cj minus Zj. So what is this Zj, what is the Cj minus Zj? Let's have a look at these calculations. So Zj is the sum product of this Cb part and x. So it's a summation of Cb and these x variables, maybe x or y or S1's variables or x2's coefficients, S3 and artificial variables coefficient. So what I'll do, I'll multiply them and add them up. So 0 into 2 is 0, 0 into minus 3 is 0 and minus m into 1 is minus m. So I have to write here minus m. Then 0 into 3 is 0, 0 into 2 is 0 and minus m into 1 is minus m. So accordingly, I have to calculate all the values of Zj. Then what is this Cj minus Zj? I have to subtract the elements of Cj from Zj. So 6 minus of minus m, that will give me 6 plus m. 4 minus of minus m is 4 plus m. Then 0 minus 0 is 0. 0 minus 0 is 0. 0 minus m is minus m. Minus m is 0. The objective here is to have Cj minus Zj's values as either negatives or zeros. So here we have zeros, we have negatives, but these quantities are positive values. So I need to do something in order to have a conversion from these positive values to the negative values, and that particular thing is called as an iteration. So we'll be performing the first iteration here. Till now we have written or we have formalized the linear programming matrix. Now we have to choose maximum of all the elements from Cj minus Zj. So from Cj minus Zj you can see that the maximum number is this. If you have a confusion, you can substitute some value in place of m. Let's say if I substitute 100 in place of m, I'll get here 106 and I'll get here 104. So which of the quantities would be bigger? This would be bigger quantity. So I have to choose this column as my key column. So this column is to be chosen. So I have to select this column as the key column. Then to find out the row part, I have to go with the minimum ratio thing. So minimum ratio is the ratio of solution and the elements of these elements of the key column. So 30 divided by 2 will be 15, 24 divided by 3 will be 8 and 3 divided by 1 will be 3. So I have to choose minimum of all these 3. So minimum is 3 from all the elements. So 3 is minimum, that means this 3 part is your key row. So this indicates that this one is the key row. What does this key column and key row indicates? So if it is key row, that indicates that x would be the entering variable, and if it is this 3 which is the key row, it indicates that artificial variable 1 will be the leaving variable. So in place of in the next iteration, I will be writing in place of artificial variable 1, I have to write this x. So that means key row indicates the leaving variable and key column indicates the entering variable. So in the next set of iteration, I will be substituting artificial variable 1 as x, and this would be removed. So this would be the case when I have substituted x in place of artificial variable 1, and the coefficient would be of x only. So the coefficient of x is 6, so I have to substitute here 6. Now there is also one step, and that step says that the intersection of key row and the key column should be 1 always. So this is already 1, but if it is not 1, let's say this value is 3, so I need to divide the entire row by 3, so that this part becomes 1, this key element becomes 1, and additionally the other elements which are connected with the key element, that should be 0. That means I'll try to make this element as 0 and this element also as 0 by the row operation, and the row operations would be this R1, which is R1 new, it changes to R1 old minus 2 times R3 new. And similarly for the second row, that would be R2 new, it changes to R2 old minus 3 times R1 new. So depending upon that row operation, I need to multiply this quantity with 2 and subtract them, and multiply this quantity with 3 and subtract them. So after doing the row operation, I'll get some elements, and these elements would be listed here. After doing the row operations, I'll get some elements, and those elements are listed here. Now I got the second iteration. Now what to do with that iteration part? I need to check that the solution is an optimal solution or not. So for that, I need to find out Zj values. So what is Zj? Zj is the sum product of all these values. So I'll be doing 0 multiplied by 0 plus 0 into 0 plus 6 into 1. That would give me a value 6. Similarly, 0 into 1 plus 0 into minus 1 plus 6 into 1, that would give me a value 6. Here you must have noticed something different apart from the previous condition. So whenever I had to remove this artificial variable, I have to remove it from here also in my next set of iteration. So here you can see that the key row indicated that this artificial variable is to be removed from this basis. So when I remove it from the basis, I need to remove it from here also. So you must have noticed that this artificial variable 1 column was also deleted from in the next set of iteration. So we were doing Zj calculations. So I have told you that it's a sum product of these two columns. So I have written that. Then the next set, this column and this column is to be multiplied and added. We'll get some values. And then finding out Cj minus Zj values. So Cj value is 6, Zj value is also 6. So 6 minus 6 would be 0. 4 minus 6 would be minus 2. 0 minus 0 is 0. 0 minus 0 is also 0, and 0 minus 6 is positive 6. So here you got all the elements as either zeros or negative, but here you got one element as 6, which is positive. That means your particular part or the particular matrix or the solution is not optimal. So you have to repeat the same procedure to make it optimal. So what is that same procedure? You have to choose this element as the key column. So this part is to be chosen as the key column. So this one is to be chosen as the key column, and then you will divide this key column with the solution. So solution is this and key column is this. So you will divide both the elements. 24 divided by 2 will be 12, 15 divided by 3 will be 5, and 3 divided by minus 1 is negative. So we generally avoid the negatives values. So we have to skip it. We have to choose in between the two. So 5 is the least of the two. So we have to choose this 5 as our key row. So key row indicates that this S2 is to be removed, and in place of S2, S3 is to be placed. That hardly makes any difference, but it will make a difference in this solution aspect when we go for the row operation in the next step. So we got that S2 is to be removed from this table, and in place of S2 we have to enter or we have to substitute S3. Additionally, we have got one element which is the intersection of key row and the key column, and that element is this element. This element is called as the key element, and the rule says that we have to make this key element as 1 and remaining elements which are corresponding to this key element as 0. So in order to make this as 1, I have to divide the entire row by 3. So the operation would be R2 changes to R2 divided by 3. So that would be the row operation in order to make this element as 1, and remaining elements are to be made as 0. So I'll apply this row operation. That would be 2 minus 2 times of this 1, because this would become 1. And for the next set, which is this minus 1 is to be made as 0. So minus 1 plus 1. So R3 changes to R3 plus R2 new. So after performing the row operation, you will get a new matrix. Firstly, when you divide it, you will get some elements, because I want to have the value which is 1. And after doing that particular stuff, we'll be dividing or we'll be applying the row operation in order to get the elements as other elements as zeros, right? So I got 1 here and I got other elements as 0 after applying the row operation. Then I have done the iteration. Now for after performing the iteration part, I need to check that whether this solution is an optimal solution or not. So for that, we need to find out Zj and Cj minus Zj values. So the step is similar. I need to have the sum product of these two elements, these two columns. So 0 multiplied by 0 plus 0 into 0 plus 6 into 1. I'll write here 6. So I'll get some elements after having calculated those Zj values, and then I'll calculate Cj minus Zj. So 6 minus 6 would be 0, 4 minus 4 will be 0, 0 minus 0 will be 0, 0 minus 2 is minus 2, and 0 minus 0 is 0. So I'll get these elements as either zeros or negatives. So I got all the elements as zeros and negatives. What does it indicates? It basically tells that the solution is an optimal solution. And what is that optimal solution? This would be that optimal solution. That means finally I'll get the result in which x would be equal to 8. This solution do not have y, so y is 0, and the value of S1 is 14, and the value of S2 will be 0 because S2 is not here, and the value of S3 would be 5. Although this S variables do not make any difference to the objective function, so what would be making a difference towards the objective function? That would be x only. So how to calculate the Z max part? That would be 0 into 14 plus 0 into 5 plus 6 into 8. So 8 into 6 is 48. That means the maximum value after having the elements of x as 8 is 48. So this would be the final result after the optimization. And what kind of problem we have undertaken? The kind of problem is the more than type situation of the constraint equation. So this is the final solution after having confirmed that Cj minus Zj values all are either negatives and zeros. So this would be the final solution of the same. We stop here for a short break. After coming back from the break, we'll do more related problems which are based on the Big M method. Thank you.
Now quality learning is easily available at your doorstep. S. Chand Academy brings detailed lectures based on UGC curriculum as per the New Education Policy 2020. So do not forget to subscribe to the S. Chand Academy and access the wide world of knowledge conveniently sitting within the comfort of your home. Stay connected and keep watching S. Chand Academy. Happy learning!
Welcome back to S. Chand Academy after the break. Before going to the break, we have learnt about the Big M method, and we have seen that we have used an artificial variable in order to convert the more than type constraint into an equal to type constraint. Now in this part, we will be having one more complex problem of the Big M method related to the similar type of situation. So the problem which is based on the Big M method is although having the similar aspects, but the objective function is different. So the objective function in the previous case was of the maximization type. That means you need to maximize the profits or you need to maximize the outputs. But here the case is of minimization. That means let's say you have to minimize the time of the production. So you want to produce the items in a minimal period of time. So for that, minimize is the objective function, and remaining are the constraint equations that you have in the particular set of the formulated problem. So what is the basic aspect? So in majority of the books, you will find different methods for minimization and a different method for maximization. But what we will do here, we will try to correlate this maximization and minimization so that one can learn some steps of the maximization type situation and apply those steps in the minimization type problem as well. So there is no need to cram certain steps for maximization and certain steps for the minimization. We will try to correlate. Now let's have a look at the solution. So firstly, what we need to do, we need to convert this minimization type problem into maximization type problem. So how do we do that? In order to convert this minimization type problem into the maximization type problem, we have to use this maximization star part. So I am writing maximize star z star, that would be equal to minus z. So if I multiply this entire equation by a negative value, then I will convert this minimization type problem into a maximization type problem. That means z star, which is a maximization type objective function, that would become minus 4x minus 3y. So this would be the case of conversion. So you can do any type of problem, whether it is a maximization type problem, whether it is a minimization type problem. You have to convert, or you have to look for every type of problem should be maximization type. If it is not, let's say if it is a minimization type, we have to convert it into a maximization type problem. And rest of the steps are similar. So I have this objective function, I have this more than type constraint, I have less than type constraint, and I have more than type constraint. So in order to convert the more than type constraint into an equality, so I have to use minus S1 plus artificial variable, that would be equal to type constraint. For the second case, it would be of less than type constraint. So say in the similar grounds, we have to use a slack variable to it. And the third equation is of more than type. So I have subtracted the surplus and added artificial variable to it. I will get an equal to type constraint. Now what happens to the objective function? The objective function, as I have told you, is of maximization type, and this was the situation in the previous step. In the next step, when we are converting it into a standard form, what we will do, we will look for all the s variables like this, this and this, and multiply all these s variables with 0. And wherever there are artificial variables, I need to multiply those artificial variables with m and subtract it from the objective function. So I need to write minus m a1 and minus m a2 here. This itself indicates that this is the big M method, because we are using m with artificial variables. So m is a larger quantity that would be using. Now the thing is to use that same format of the table that says profit, which is CB, basis, solution, x, y, s1, s2, s3, artificial variable 1, artificial variable 2. From where do we get all these variables? From the objective function, we got all these variables, like we got x, y, s1, s2, s3, a1, a2. So we have to write all these variables in this table, and we have to choose something in this basis part. So what to choose and how to choose is this part. Whenever you are having S, which is surplus and artificial, and the choice is between the surplus and artificial, you have to choose artificial variable. When there is a choice between decision variable and the slack variable, you have to choose the slack variable. When there is a choice between surplus and artificial, you have to choose the artificial. So here for the first equation, you have chosen artificial. For the second, you have to choose the slack variable, and for the third, you have to choose the artificial variable. So these are to be chosen. And for the coefficient, you have to look for the objective function. Like for A1, the objective function is having the coefficient minus m, so you have to write minus m here. And for the next S2, you have the coefficient 0, so you have to write 0 here. For A2, you have the coefficient minus m, you have to write minus m here. This is the same step, same type of procedure that we have seen in the question that we did before going to the break. So, rest of the elements you have to write from the equations coefficient, and the thing is to calculate Zj and Cj minus Zj. This Zj and Cj minus Zj we are calculating just for the sake of checking that whether this type of solution is an optimal solution or not. So, Zj is the sum product of these two columns. So, minus m into 2 plus 0 into minus 3 plus minus m into 1. So, when we multiply and add them up, we will get an element that would be in terms of m, that is minus 3m, and similar for the other cases. And Cj minus Zj is also to be calculated. So, minus 4 minus of minus 3m, which is minus 4 plus 3m, minus 3 plus 2m, that would be this case. 0 minus m is minus m, and 0 minus m and other elements. Now, what to look for? We have to check whether this elements which are Cj minus Zj elements, all the elements are either negatives or zeros. If they are, then we will say that the problem is then optimized, then the solution is an optimized solution. If it is not, we have to iterate it again and to get an optimal solution. So, here it is not, so we have to look for the bigger number. So, minus 4 plus 3m is a bigger number. So, from there we have to choose this column and name it as a key column. It indicates that x would be the entering variable, and for the leaving variable we need to look for the minimum ratio. So, for that we need to divide the solution and the x elements. So, 10 divided by 2, 6 divided by minus 3 and 6 divided by 1 would be the elements of the minimum ratio. Here we generally skip negatives. So, we are having the choice between 5 and 6. So, we have to look for the element which is smaller. So, 5 is a smaller element. So, that indicates that this part would be the key row, and the intersection of key column and the key row will indicate this element, and that element is called as key element. Now, what does this key element indicate? That we need to make this key element as 1. So, for that we have to apply a row operation, which is dividing the entire equation by 2, and the other element should be 0. So, we have to apply the row operations in order to make them 0. So, this is the elements or the operations that we would be doing. So, after applying those operations, we will get some elements. So, we will get more elements, and here you have seen that the artificial variable 1 was removed from the basis. So, I have to remove this from the overall matrix. So, I have to remove them. Then again I have calculated Zj and Cj minus Zj by the same procedure. Here I am not getting all the elements as zeros or negative. So, I have to choose the element which one is a bigger element. So, this one is a bigger element. Similarly, we got the key column and the key row. So, for key row I have to choose the minimum. I have to choose the key column elements and solution elements. So, I have to divide both of them, and I have to choose the minimum element. So, this is the minimum element that indicates artificial variable 2 is to be removed, and in place of that y is to be substituted. So, I have to remove this artificial variable 2 and I have to add this y in place in the next iteration. After performing the iteration, I have to perform the similar steps, which is making the key element as 1 and the remaining elements which are other than the key elements as 0. So, these are the row operations. After applying the row operation, I will get these elements which are highlighted in red color, and others are highlighted in the black color, which is the first row operation. Then after getting these, the idea is to check whether this solution is an optimal solution or not. So, for that we have to go with Zj and Cj minus Zj calculations. So, Zj is I need to go for the sum products of these two elements and get some numbers. So, these are those numbers, and then Cj minus Zj are to be subtracted. So, minus 4 would be 0, minus 3 would be 0, and again 0 minus 1 is minus 1, 0 minus 0 is also 0, and 0 minus 2 is minus 2. Here you got all the numbers of Cj minus Zj as either zeros or negatives. That indicates that your solution is an optimal solution. So, what would be the solution? Your solution would be this: x value is 4, the value of y is 2, and the value of s2 is 16. So, ultimately S2 value has no role The solution, value of x is 4 and the value of y as 2, and z star max value would be minus 4 into minus 4, which is minus 16, and minus 3 and minus 2 is minus 6. So I'll get a negative number. So maybe minus 22, I'll get a negative number. Now what to do? You may remember that we started this question with a minimization type objective, and we converted that minimization problem into a maximization type problem, and we performed the similar steps. But we require the minimization objective. So z minimum would be the negative of minus of z star max. So z star max, I got the value of minus 22. So when I substitute here, I'll get the value of minimum as z minimum as 22. So we followed the same protocol that we have seen for the maximization type problem. We converted minimization into a maximization type problem and performed the similar steps as we did for the maximization type problem. So with this, we come to the end of the Big M method, in which we have seen two different cases. One case was related to the general type, which is maximization type problem, and the second case was related to the minimization type problem. So we have used or interlinked a common procedure with both the type of problems. Thank you.
If you want to study this topic in detail, refer to these books from S. Chand Publishing and Vikas Publishing House. Link is provided in the description box. If you found our video interesting, please like, share and subscribe. And do not forget to press the bell icon.
All rights reserved. This video has been prepared for educational purposes only. No part of it may be reproduced or copied without the permission of the copyright holder.